Hello, this is the first part of the 2013 Oxford PAT, which, if anything, should be easier than the 2012 one, which was a little over the top in complexity. Doesn't look as though anything's changing here. We've got two parts, 50 marks on each bit, starting with maths. Still can't use calculators. G's still 10. Exact answers in the maths and two significant figures in the physics. Right, so we're kicking off with a geometric series here. We're multiplying by minus a third all the way through from term to term. So sum to infinity for a geometric series, a over 1 minus r. First term is 2/3, and then 1 minus r is going to be 4/3 because we've got this minus a third factor. So 2/3 divided by 4/3 is a half. Don't get a much nicer starter than that. If y is that and all of that is equal to u, find an expression for x in terms of u and v. So eliminate y is what we're saying. So, well, we'll just sub in y into here and then rearrange for x. So we've got root xv minus root x all squared equals u. So square this out, xv minus 2x root v plus x equals u. Factorize the x, xv minus 2 root v plus 1 equals u, and then divide everything through. So we've got x is equal to u divided by v minus 2 root v plus 1. Right, not very exciting question, but 3 easy marks. 50 people are in a room. 8 people in the room have red hair. 3 people have black hair. 20 people are male. You may assume that hair color and gender are independent. If a person is selected at random from the room, what is the probability they will be female with red hair? So we need both of these things. So probability of female, which equals 3 out of 5, or 30 over 50. So that's 3/5. And then we need to multiply that by the probability of red hair, because these things are independent of each other. So that is 8 over 50. So we need to multiply these things together. So that is 24 over 150, which is 12 over 125. I don't think we're going to do any better than that, are we? Yeah. So that's that one. If the person is selected at random from a room, what's the probability they will be male who does not have red or black hair? So we need 2 over 5 multiplied by 11 who do have red or black hair. So it will be 39 over 50. So we can cancel that with, make that a 25. So we've got 39 over 125. Right, that was another straightforward question. They've been very kind to us in this first part here. I'm sure it will start kicking off in a minute. Show that x is 1 is a root and then factorize. Okay, so we've got 1 cubed minus 1 squared minus 4 plus 4 equals 0. Therefore, x equals 1 is a root of f of x equals 0. Hence factorize, so we've got x minus 1. So we'll need an x squared, we'll need a minus 4, and then we'll need, so we need minus, oh, we've already got minus 4x off of that. So yeah, we've got nothing else to put in there. We've just got a difference of 2 squares, x minus 2, x plus 2. Find the remaining roots. So we've got x equals 1, which we already had, and then 2 and minus 2. So that's good. Having found the roots, find the area bounded by the curve and the x-axis between the two smallest roots. So we need to integrate from minus 2 to 1, because they're our two smallest ones, of x cubed minus x squared minus 4x plus 4 with respect to x. So that is x to the 4 over 4 minus x to the 3 over 3 minus 2x squared plus 4x minus 2 and 1. Right, we might have some slightly annoying numbers on all of this. So we've got a quarter minus a third minus 2 plus 4. Then we need to take off, so keep that bit in brackets. We're going to have 4, because we've got 4 times 4 divided by 4. Then we're going to have, what's that, 8 over 3, and the minuses will cancel out to give us plus 8 over 3. Then we've got minus 8, and then we've got minus 8. Okay, so all of that gives us, what have we got here? We got a 4 minus a 4, so they cancel out with each other by the look of it. So we've got 16 and a minus 2, so we've got a 14. We've got, forgotten what we've got left here, plus a quarter, minus a third, and then the minus 8 over 3, so that's minus 2 and 2/3. So that leaves us with, that's 3, so 11 and a quarter. All right, so it's just messing around with primary school numbers. No, this is going very easily. Maybe they're feeling sorry for people after, well, I suppose they wouldn't have sat the previous year, but maybe they recognised they went a bit far in 2012. So if x is equal to that, find x and y. So we've got x is equal to, well, that's 2 for log base 10 of 100. Then we've got a half, oh no, 1 for the next one, because it's root 25. So 5 log to base 5 of 5 is 1, minus, okay, log base 3 of what, well, let's put the 2 down the front. So we've got that for the first equation. Then we've got x over 2 is equal to 3 minus, well, that's 9 over 2, and then plus 2 log 3y. Oh, that's nice. So we can add those up, and that's going to give us 3 over 2x. So we add those. Add gives us 3x over 2 is equal to, what's that, 6 minus 4.5. So, yeah, that's what it comes out, isn't it? Yeah, 6 minus 4.5. So that is 1.5. So x is equal to 1. That's good, which means that, what have we got? Okay, so we can put it in the first one. 1 equals 2 plus 1 minus 2 log base 3y. Cancel those, divide by these, so y is equal to 3. Okay, log questions are always nice. I know I say that on every paper, but they always are. Find the equation of the straight line that passes through the centres of these two circles. All right, so we don't even need to get anything to do with the radius of the circles or anything like that. So we've got a centre of this one is going to be at minus 2, 1. Because you only have to look at what's going to be inside the bracket when you complete the square. And this centre is going to be at 2, 3. So that's given us the centres. So the gradient is going to be equal to the change in y. So 2 we've gone up, divided by the change in x. 4 we've gone up. So the gradient is equal to a half. So we've got y, just has to go through either one of these points. So let's say it goes through this one. Y minus 1 equals a half of x plus 2. There you go. That was ridiculously quick, 5 marks. So yeah, insanely straightforward. How many terms in the binomial expansion would be needed to determine this to 1 decimal place? Well, we can trim this down a little bit, can't we? So 3.12, you're always looking for factors here. So just make it a little bit easier. We got 3 times 1.04 to the 5. That's certainly going to help. So we've got 3 to the 5 times 1 plus 0.04 to the 5. Okay, we do have to work out what 3 to the 5 is on all of this. So 3 to the power of 5 is equal to, well, I suppose we just keep on increasing thing. So we got 81 times 3 times 3, which is 243 times 3, which is 729. Right, so we've got that bit, 729. And then we're going to be doing 1 plus 5 times 0.04 plus 5 times 4 times 0.04 squared over 2 factorial plus 5 times 4 times 3 times 0.04 cubed divided by 3 factorial. So we just need to, well, we know what we're going to, 1 decimal place, and we're multiplying by this 729. So we're going to need to get quite a long way down. So it's certainly not going to be this, because we've got 1 plus 0.2. Then we've got, what's this going to be? That's going to cancel with that to make a 2. So we've got 10. So that's going to come out at 0.016. So we're still nowhere near where we want to be. That can cancel with that to make a 2, which can cancel with that to make a 2. So we've got 10 times 0.04 times 0.04 times 0.04. Okay, so that is going to be 4 cubed, which is 64, times 10 to the minus 5. Are we getting there yet? So that's 0.00064. When we multiply that by 729, we are still going to be getting to 1 decimal place. So we're still affecting things there. That definitely will get up to that, because we've got the hundreds are getting us up to here, just because it's 700 and something, and then multiply by 7 is going to get to at least a 4 there. So we definitely need that one. So if we go down another one, we'd have 5 times 4 times 3 times 2 times 0.04 to the 4 divided by 4 factorial. So that'd be 24. So what's happened on this one is we've dropped by a lot. We've dropped by too much. That won't get into 1 decimal place, because we're dropping back by 3 decimal places there pretty much. So, or maybe 2, but either way we're not going to get up to there. So we've got 4 terms because this is just too small. Yeah. Okay, that's again, so far so good. Where are we? Oh, we're on to sketching now, so which they still really liked back in the day. Sketch the regions in the XY plane defined by these inequalities. Right, okay, so we've got, this is going to be interesting, I think. Well, maybe it won't be, but you never know. So we're going to have, for x is greater than or equal to 0, we can just divide through by and multiply through by these x's. So we've got y has to be between 2 over x and 1 over x. That's one of them. And then we've got x over 2 and 2x. Okay. And then when we're less than 0, we're just changing all the signs around. Inequality signs. So we'll go in the other way round. X over 2, y and 2x. So we've got 4 graphs that we need to draw out here. So change of colour, I think, is in order. We need to draw y is 2x and y is x over 2. So we can draw in that one there for y equals 2x. We can draw in that one there for y equals x over 2. Then let's go for a green. So we got a 1 over x, which is going to be looking something like this and something like that. And then, so that's y equals 1 over x. And then we need 2 over x. So that's just doubling that up in the y direction to do something like that and something like that. So this is y equals 2 over x. So the bits that we need for x is greater than 0, we need to be between all of the lines. So we've got this bit here, and then, well, we've got exactly the same for less than 0. We have to be between all of the lines again, so we're going to have that region there. But it's just changing the orientation, that is, in when we're at positive x, y has to be below the 2x line, so it has to be this side of it. Whereas when we're on negative x, it has to be above the 2x line, so it has to be on this side of it. So that's how we're getting the same region on either side. So 7 marks. Oof. Okay. Oh, more sketching. Sketch y is equal to e to the minus x. Oh yeah, just clarifying what that means. Yeah, weird way of putting it. It's sort of a computer way of writing stuff. So yeah, if we're going to have that, we're just reflecting in the y-axis there. So I'm going to squeeze it in here because the other one looks horrible. So we're just going to get that going through 1. So yeah, that's an easy sketch to do. Now sketch B, let's write this out in sensible format so we can actually see what's going on. So we've got y is equal to 3, then we got a big bracket, e to the minus 2 times x minus 1. Okay, so that's dealt with, yeah, that's all one lot of brackets, minus 2. It's hard to see what the brackets are doing here. So the minus x minus 1. Okay, and then we close the big bracket. Right, okay, so we're multiplying everything by 3 on all of this. Right, I mean, I suppose I haven't put a hence on there. It feels as though they're setting you up for something here by saying, oh yeah, we've got this e to the minus x, and now we've got variance on it. But then subtracting one from the other makes it very hard to tell exactly how it's going to behave around the small x region. So I think I'm just going to go down the usual route then. We're saying, right, when x is 0, y is going to be equal to, so we've got 3 times e to the e squared minus 2 times e. Okay. Right. When x is positive infinity, then we're going to get, actually these are going to be tiny. So we're going to get very small minus very small multiplied by 3. So it's going to, y is going to go to 0, but on what side is, which one's going to be bigger out of these? That's going to be smaller because we're doubling it. So this is going to be bigger. So it's going to go to negative 0. It's going to be below the axis. So, okay, that's good. When x goes to negative infinity, both of these are going to be enormous. So y is going to go to infinity. Okay, so that's good. Let's put in some of the bits that we've got already then for all of this. So we know we have to end up here in some way. We know that we've got a asymptote going off this way. We know that we've got a value here because that is going to be positive, isn't it? Because e is greater than 2, so that will be positive. So it's coming through here at whatever that value is, this 3e squared minus 2e. So we need to know turning points, and for y is equal to 0. So yeah, let's do y is equal to 0 when these things are going to be equal to each other. So we've got the and we can flip the signs on these, can't we? So we can say 2e to the 2x minus 1 has got to be equal to e to the x minus 1. Okay, so we can log both sides, say log 2 plus 2 log of that, yeah, 2 lots of, yeah, this is going to be right, yeah, log 2 plus 2, where am I going, x minus 1 is equal to x minus 1. So we've got that Well, that will cancel with that. So we've got x is equal to 1 minus log 2. So we've only got one solution for y is 0 so natural log of 2 is less than 1. It's about 0.7. So we must be coming in about here then. So that, right, it looks like we're going to have that coming down. It's meant to be a bit smoother than that. If we can find one turning point, so that's at, what did we say that was? 3 times e squared minus 2e. That is at 1 minus log 2. So all we need now is the turning point, and then probably to redraw it as a smoother line that looks a bit, well, that's still not that smooth, but you can see what I'm getting at. So the turning point is going to be, I mean, it's for 8 marks. It's probably worth doing this because they're probably after it. So we need turning point. What we're going to have, so y dash is equal to, my word, right, so we got a minus here, so minus 6e to the minus 2 x minus 1. And then what have we got? Plus it's going to be, because we've got a minus 1 coming down, plus 6e to the minus x minus 1. So we're going to have a turning point when these things are equal to each other. We can divide by the 6's, and then we can say that what we got, oh yeah, these e's have to end up being the same. So we have to have that 2x minus 1 is equal to x minus 1. So x must be equal to 1, so that fits, which means that y would be equal to, it's making both of these things 1 minus 2, so minus 3. Okay, so we've got a turning point at 1 minus 3. Right, okay, so that's made a little bit of a mess of my picture, but the final picture that we've got on all of this is a graph that's coming around doing something like this with, right, that's a terrible way of drawing it. Oh, good grief. Get this right in a minute. It's so hard to draw on this stupid thing. Right, so yeah, something like that. That's what we're getting at, that smooth curve with all of these values that we've worked out. So yeah, that's a really, really difficult graph sketch. But again, it's about being logical on these things. You see, we've gone through the same steps. So x is 0, y is 0, x is plus infinity, x is minus infinity. Then we've got the turning points. So those three things on their own have given us where do we end up at either end, the extreme values of x, what are our interceptions on the x-axis and the y-axis, and what are our turning points. So it's the same steps again. Okay, these are very difficult steps, which is why they're giving you 8 marks. But still, even if you make a mistake on one of them, it doesn't really matter that much, because you're still picking up loads of marks by taking this this logical step-by-step approach. So setting it out, you can obviously set it out a bit more clearly than I've put here, because I'm trying to squeeze it all on one page. But yeah, you can start putting in a few little things like, when x equals 0, and then y equals, and then solve everything, and then boom, 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 and then you can have there that y is equal to whatever it was. So just lay things out, do one bit, line under it, maybe literally a line under it, and then say, as x tends to plus infinity, y tends to negative 0. Move on to the next bit, laying it out that way, and then gradually just piecing up your picture as you're doing everything. Yeah, gets you a lot of marks, even if you make a mistake. Right, we've got another one. It feels like we've done quite right. This is the last one, the geometry question. So in the figure below, all triangles are equilateral. Find the shaded area in terms of R. So we've got, what is the shaded area? So we've got the big triangle, then we take off the big circle, then we add in the little triangle, and then we take off the little circle. So that's what we're trying to work out in all of this. So the big triangle, we know, right, so we know that is 2r because we've shown that loads of times before, which means then we've got 2r there and another 2r there. So actually these things are just scaling each other up. Yeah, this is just 4 times bigger. We've got the same thing and then 4 times bigger on the outside. So yeah, this is going to be easy, isn't it? Because you can see we've gone from a radius of the small circle is r to the bigger circle is 2r. So doubling the length is going to quadruple the area. We got exactly the same for the triangle. So we work out one and we got the other. So we got pi r squared for that. So that'd be 4 pi r squared for that. Then for the small triangle, we've got to do the half base times height, which is what we always do off of this. We've got 60 degrees there. So we know that half base is 2r times sine 60. So that's root 3r. So we've got 3 root 3r squared for that. And then we just multiply that by 4. So it's worth saying that we can say that equals 4 times, oh, I've got some weird shape has appeared there. That equals 4 times, I don't know what's happening there. Anyway, you can make some statement that these are 4 times. I've got striped lines appearing all over the place now. But yeah, we'll say those things are 4 times the area, and there we go. We've got all of this. So we've got 15 root 3r squared minus 5 pi r squared. So we can factorize the 5r squared. So we've got 3 root 3 minus pi. Wow, that was a quick 7 marks. That was really quick. So shows again the value of not necessarily doing everything in order. If you can pick up 7 marks as quickly as that, then go for it. Yes, particularly if you might get slowed down by what was quite an unpleasant question 9, which was very difficult. The others, though, I mean, I really like this set of questions. They're not easy questions, but they weren't ridiculously difficult. They're covering a lot of different areas and they're all manageable. So I would say that this, unlike the previous 2 years with the maths questions, this is a realistic 100% within the hour section. You know, that's not to say that you'd need to get that, because there's still some difficulties there, particularly question 9. But by and large, that was a really nice set, I think. So yeah, that brings to the end this happy set of questions for the first part of 2013. And hopefully this will continue in the rest of the paper.